at the end of the lesson, you are expected to identify cross-validation, use Python to do cross-validation, and appreciate the significance of cross-validation in machine learning. If we would like to test the predictive performance of our model, it is always necessary to use a validation data. But then the question is that, where are we going to get our validation data? So first, a validation data can be taken from a set wherein our training set is a part of. Okay? And the second is that we can get our validation data outside of the set wherein our training set is a part of. Okay? So having different models at hand, we can train each one of them on the reduced training set, right? So that we have chosen. So remember that we said before in our past lesson, in our previous one, that we should make different kinds of models because these models would be able to help us identify which one could give us the best generalization of our data. Okay, so after each one is trained, we can then compute and compare the respective losses on the validation set. Okay, so of course we always expect a decreasing loss as the polynomial order increases. We had that in our previous lesson, and I'm going to provide the link to our previous one below, and be sure to watch it because understanding this lesson would be more meaningful if you do understand our previous lesson. Okay, so but then again, this kind of hypothesis can be tested. Okay, our hypothesis is that the more attributes we have, or the more parameters we have, the less loss, or the lesser loss we're going to have. Or in other words, if our polynomial order is higher, then our losses also decreases. So having all of these discussed, I believe our mind always wants the best and the efficient use of data. Of course, that is always our objective. How are we going to best use our data, right? But the question is how? How are we going to do that? So this is where the idea or the value of cross-validation is highly appreciated. So let's remember that the loss calculated from the validation data is sensitive to the data that we have chosen. So this gives us more headache when we only have a very small data set because our choices are very limited and we may not be able to make more divisions so that we would be able to slice our data set in as much or in as many as possible subsets. Okay, so cross-validation comes in to remedy the problem. So the most effective of its kind is what we call the k-fold cross-validation. So what is this? What kind of method is this? This method, it divides the data into k equally parts. Okay, so maybe you would like to ask me, how are we going to, how many parts the data should be divided? Of course, it depends upon you, but you have to bear in mind this test. Does this division give us the proper understanding of the different subsets or the different insights we can get out of the data? So that is our test always that we have to remember. So the mechanics of this process are, the first is that we are going to take turn, or each part takes turn as the validation set for a training set. So this is the first thing that we're going to do. And second one is that we get the final loss value by taking the average of the k-loss values. Okay, so let's have this one as an example. So you could see here a circle which is divided into 4, just to say they are of equal parts. Okay, so what we will do here is that, okay, first this one, this would be our validation data first. and then this one is our training set, right? So we have 3:1. Okay, and then the next is that this will become our validation data for our second turn, and 1, 2, and 3, all of these parts now would become the training set. Okay, third step, this part now would become our validation set, and then this and these parts would be our training set, and then lastly this part would be our validation set, and then these parts would comprise the set for our training set. But then of course, if you do have 10 parts, you're going to do that 10 parts. So you can do the validation for as many parts as you have, or as many divisions you have in your data. Okay, so I think that is very much clear, and now we're going to understand more about this using Python. So let's go there. Before we continue, hit that subscribe button to enjoy more our deep learning, mastering machine learning algorithm, and natural language processing courses. Click the notification bell to receive more updates. Okay, so let's go now to how we're going to use Python to do the cross-validation. So this is going to be very exciting. Okay, we will have this one step by step. Okay, of course, the first thing that we're going to do is that we are going to import the necessary libraries. So we've imported pandas, as you can see in here, and we've also imported NumPy, and we also have the sklearn. So where or why do we import them? What are their uses? I believe you know them already. However, I would like to mention this one over and over again. So let's have first the pandas. Okay, pandas is used for us to easily manipulate our data. And then we have the NumPy. NumPy is used for scientific calculation or computation. Of course, in this kind of thing, we're going to make scientific calculation. So that's why we've imported NumPy. And of course, a sklearn. This is a machine learning library for Python, and we need this for us to be able to do the machine learning thing. Of course, we're dealing with machine learning project. Okay, the next thing is that we're going to read our data set. So here we use NumPy or pandas to read our data. Okay, let's first, all right. Okay, and of course, in our case, we are using the Boston house price data set for our activity, and we can see that we have here two method that we use for us to be able to understand, at least to have an overview of our data. So we can use this method, and if we're going to execute this, we are then given this output, and these are the different values we could see in our data set. And with that, we also have another method for us to see what is inside our data set. So we have in here, and if we're going to execute this, then this gives us this result or this output. So it gives us the 505 rows and one column. So it gives us a different value for each row. So we have here. So all in all, we have again 500 rows, and then we have one column. Okay. So, and then because we have already identified and we have already have an overview of what the data set is, it's time to have the pre-processing of our data, which is really very important. So our step number 2 is actually just a raw data, nothing less, nothing more, just a raw data. Okay, so here in our step number 3, we're going to do some kind of processing. This is really very challenging because this is where the analysis really starts. Now, so what do we do in our pre-processing stage? So here, again, we pre-process here our data, but why do we have to pre-process our data? What's the idea behind it? So pre-processing helps us determine the different features and the output attributes of our data. So as you could see in here, we could see that we have 0 to 12 column index, and that is for the value of x, and for y we could see the 13. Okay, the index 13 represents our dependent variables. Okay, so if we're going to print x and y, then we could see that it gives us these values for x. So this is actually 12 for each row. So we have 1. So if we're going to have it red, then that will really give us 12 for each row. And okay, and for the index 13, these are the different outputs. So it's actually longer, a lot. Okay, now so here you can see that in our pre-processing stage, we just do not limit ourselves to just identifying what are these data in this particular indexes, but we also have to normalize our data. So we have this code or process on how to normalize our data. So this is normalize. Okay, wrong spelling. So as you could see in here, we use the min-max scalar, and this min-max scalar is used to normalize a certain data set. And maybe you would like to ask me, why do we need to normalize our data set? Okay, so the answer is that normalization is really very important for us to be able to rescale our data to have a value between 0 and 1, because if we are not going to do that, some data or some values in our data set would be too much higher in comparison to others, and if we are not going to normalize that, then that will be giving us much chaos, because our predictive value later on, our performance would really be affected because of the variance between the smallest and the biggest value. So we have to limit the range from 0 to 1 for the values to be normalized. So we had a lesson on that. Please check on the playlist Deep Learning Mathematics, and there I discussed the different methods on how to normalize a certain data. So you could learn a lot from there. So as what I have said, this gives also the assurance that one feature does not affect the final prediction for or more than what others do. Okay, so as you could see in here, after we applied the normalization using the min-max scalar process or method or tool, shall I say, then we have this value 0 point blah blah blah. Maybe you would like to ask me, why is that we have 2 point and that is bigger than 1? Actually, it's not, because it's actually negative. If you're going to make it in its transform it in its normal form, it's going to be 0.00 something. Okay, so as you could see, everything here is normalized now. The value would be between 0 and 1, right? So now this is the most awaited moment of our project. Okay, so this time we are going to go to the 4th step. This is the most challenging part of our project and even the most exciting part. Okay, so this is really the heart of the process. This is where our validation really happens. And of course, before we go to what are these numbers, we first have to define some of the important elements in our code, because this really would give us the proper understanding of what's really going on in our data. So just for the sake, just for the sake of showing you how k-fold validation really works, what I'm showing you here is just the default parameter values. But then, of course, if you would like to meet your needs, you can change the different parameters. For example, here for the splits and for the random state, of course, you could have 45, you could have 100. It depends on you. And in shuffle, if you would like to shuffle, of course, you can just have it true. If not, then of course you could just have it false. Okay, so with this, we use the RBF kernel, as you could see in here, of the SVR model. So this will give us later on the proper prediction. So here we use the tenfold, but then, as what I've said, we could use also any number or any folds depending on your needs. So the unsplits here divides the data into 10 equal blocks, and they should be equal. And also, these are the twinning indexes here. Okay, and the testing set in each set for each iteration. And then we clearly identify the twinning and the testing sets for each iteration. And what is this? So we use the twin index, then test index here. This is actually specified in the k-fold cross-validation process. So the next equally important step is training the model in each iteration using the twin index, and then we append the error value to list scores. So let's see what's going to happen, what happens when this kind of code is executed. So once again, we've printed first the twin index, and then after that the test index. Okay, so as you could see in here, okay, so this is the division. So this is the first fold, then this is the second fold, then we have here the next fold, and so on and so forth until every after the 10th fold is given. Okay, so the twin set first, then you have the test set. So that this is the twin set, and this is your test set, right? Okay, so after we have all of these twinning sets and then test sets identified, what are we going to do then? Okay, so now is the time for us to compute the R squared. So we use the best score. Okay, as you could see just a while ago here, right? Okay, best SVR dot score. So this helps us identify the overall prediction performance we get, the overall performance. But then, okay, let's go to here first. So to get the overall performance, what we get here is the mean score. So we have here NP that mean. So for us to be able to have the mean scores, right? So when we execute this one, this gives us this. So our mean score is 0.051134 and so on and so forth. So these are the score for each part. So of course this one and this one are the same, so just never mind this one. Okay, so if you are going to count this is 11, but this and this are the same, right? So this is for the first fold, second fold, third fold, and this is for the 10th fold. Okay, and maybe you would like to ask me, is there any other way to do this? Because sometimes this becomes so tedious, and I would like to save my time because I would like to do something or another thing, and for me to do that, I would like to find another way how to compute for the cross validation method. Okay, of course, there is another way to do that, and here is how to do this. Of course, we're going to import different libraries. So we have here the cross-val score, the train test split, and the cross-val predict. Okay, so when you execute that, then you have this. Okay, so as you could see, it would still be the same, right? So 0.54 and so on and so forth. But then of course, if you would like to also have the average score, of course you can still do. And then this one, if you would like to make the prediction value or the predictive value, then you're going to do this. So these are the different predictive values using this one. What is this for? Why do we have to study this? First, cross-validation is very important in testing and evaluating the efficiency of a certain model. And second, it is used to detect underfitting or overfitting. After all being said and done, let's try this. What is cross-validation? Why do we use cross-validation in machine learning? Please leave your answers in the comment below so that we would be able to have a very rich interaction of ideas and we can learn a lot from each other. Do you want to know more about this course? Just click the card on your right screen. You can enjoy our deep learning, mastering machine learning algorithm, and natural language processing courses. Learn and upskill for free.